Let us study tridiagonal matrix. Tridiagonal matrix are matrix where elements above the diagonal elements, elements below the diagonal element, and all the diagonal elements are non-zero, and all other elements are zero. So what I mean is, let us have a matrix A. So which is 4 cross 4 matrix. There are 4 diagonal elements, 1, 2, 3, 4. All are non-zero. Elements above diagonal, which are elements below diagonals, which are elements at diagonal, elements above diagonal, and elements below diagonal. All are non-zero, or it can be zero, any of them. But except these elements, all other elements must be zero. So in tridiagonal matrix, all elements are zero except diagonal elements and elements above diagonal or elements below diagonal. Now let us study one more type of matrix, which is called as diagonally dominant matrix. Any matrix is a diagonally dominant matrix if diagonal elements, modulus of diagonal elements is greater than or equal to all other elements in row. So basically there are two conditions for diagonally dominant matrix. One is, in any row the diagonal elements should be greater than or equal to all other elements, summation of all other elements. And second condition is, at least for one row, diagonal element should be greater than, not equal to, but greater than, purely greater than summation of other elements. So what I mean here is, always we take modulus of the element. So for row 1, modulus of diagonal element is mod of n, which should be greater than equal to other two elements in row 1, which is mod of 5 plus mod of 5. So n is greater than equal to n. Yes. So for row 1, this condition is satisfied. Again, for row 2, mod of minus 8, which should be greater than mod of 2, 8, greater than equal to 8. So here again 8 is equal to 8. 8 is, so this condition satisfied for row 2. For row 3, greater than equal to so for row 3, 6 is clearly greater than 3. So condition satisfied for all 3 rows. So this is diagonally dominant matrix, which satisfies basically 2 conditions. For all rows, diagonal element is greater than or equal to, modulus of diagonal element is greater than or equal to summation of other elements in those rows. And at least for one row, modulus of diagonal element which is purely greater than other elements in the summation of other elements in that row. So if I replace, so matrix B is diagonally dominant matrix. Now consider matrix C. Here I am making one small variation. Instead of 6, let us make it 3. So condition is satisfied for row 1, row 2, and for row 3 we will have 3 which is greater than equal to 3. Now there is diagonally dominant matrix or not? No, because it satisfied first condition. For all 3 rows, diagonal value is greater than equal to or equal to summation of other element. But for none of the row, diagonal element is purely greater than summation of other row. So this is not a diagonal matrix. So matrix C is not a diagonal matrix. Similarly, if I keep instead of 3, 5, so here I will get 5. Let us assume one more matrix. But instead of minus it, I make minus 5 here. Now for this matrix D, row 1 condition is satisfied because we have not made any change in row 1. Row 2, modulus of minus 5. So 5 is not greater than equal to 8. So condition doesn't satisfy for row 2. So again matrix D is not a diagonally dominant matrix. So in summary, diagonally dominant matrix is matrix where a diagonal element in any of the row, modulus of that element should be greater than or equal to summation of other elements in those rows. And for at least one row, it should be purely equal. Mathematically, it can be written as modulus of Aij, or let me take modulus of Aii. So where both value are equal, so and must be a diagonal value element, right? Should be greater than equal to summation of I equal to 1 to n modulus of So basically there are two conditions. One, diagonal element Aii must be greater than equal to summation of all the elements in that row. So from column 1 to n except diagonal element. So I not equal to j. Summation of Aij should be greater than equal to diagonal element for all the rows from I equal to 1 to m. And Aij, second condition will be same thing, just instead of greater than equal to, there is only greater than, at least for one row, at least for one. Clear?